Hi, my name is Prabin.
Hi, my name is Deependra. We will be presenting a research project titled Simulating a Monitoring System for Police Patrol Wellness. So let's start with the summary. We as a community feel safe around us because policing authorities and officials contribute extensively in enforcing the law. However, achieving this mission in real time leads to police officials being involved in situations of excessive stress, crisis, and uncertainty that can cause detrimental impacts on the mental and physical well-being of the officers. To address this problem, we have developed a police officer stress monitoring framework that is based on statistical modeling and computer simulation. The goal is to assess and predict officers' stress level in real time. We conducted a case study in context of Arlington Police Department, and by consulting with policing experts, we defined the monitoring measures for officers' stress level. This proposed framework shows a great potential to improve and better informed policing decisions. It has been studied that the job of police officers is highly stressful, and these stressors can lead to adverse psychological and physical health consequences to an officer. It can also lead to negative behaviors like alcoholism and suicide. Due to such events, police departments have faced criticism, and that has placed even more pressure on law enforcement. To acknowledge, there has been quite a good amount of work done in the past to monitor the wellness of police officers. However, it is based on data collection using surveys and interviews, where officers are directly involved. This leads to two major problems. Firstly, data collection that directly involves human, in our case police officers, introduces sampling biases. Secondly, direct involvement of officer in data collection is time consuming. It may be stressful to officers themselves, and importantly, we cannot generalize this data for other policing structure. To make the wellness monitoring of police officers more efficient, accurate, and generalized, we have come up with a new framework that is based on performing wellness monitoring on simulated data output from the simulation model. In order to achieve this, we first collected and processed the past policing call data and then simulated the patrol operations. As an output of the simulation, we get the simulated call data, which can be used to perform the officer wellness system. This assessment can be used to make deployment decision for officers and their performance output.
We used 1-month 911 call data from 2017 obtained from Arlington Police Department in our simulation. Each call has different features such as call arrival time, call priority, crime type of the call GPS coordinates, etc. We built a hybrid computer simulation model that combines discrete event simulation and agent-based model to mimic the police patrolling operations of Arlington Police Department. We used the actual call arrival time and other information from 911 call database to generate calls in the simulation. The flow of call from its arrival to its disposal is modeled using discrete event simulation. When the call arrives, an instance of the call is generated in the simulation. Then an officer is dispatched to handle the call. Call dispatching rules differ based on the call priorities, such as the emergent calls of priority E are given higher preference over the other priority calls. Then, once the officer is assigned, the officer travels to the location of the incident and handles it. Once handled, the call is disposed. On the other hand, our particular interest is in agent-based model. It allows modeling the real-world entities as individual agents, such as officer, call center, district, etc. Each agent has attributes and behaviors that determine its state. Its state changes based on the transitions triggered by some events such as call arrival. The set of states that an agent can take are modeled using a state chart in the simulation and can be formally described using finite state machines. In the simulation, each patrol officer is an agent with attributes such as age, gender, district, etc., and their state is determined by the state chart.
Based on the call type, each call is assigned a stress level. Different call types are categorized into 5 stress levels. As part of our statistical analysis, we employed control charts, a statistical process control technique to monitor the number of stressful calls handled by each officer per week. Let's look at figure 5. For an officer with ID 6, all the observations are within the control limits, which means this officer is in normal health status. However, for an officer with ID 2, we can see an out of control case at week 6. acting as an alarm for the abnormal health status of an officer. To conclude, we built a police officer wellness monitoring framework that relies on statistical modeling and a computer simulation model to generate stress level information of officer at an individual level. As a solution, the monitor stress level of individual police officers can be used by authorities to develop policies that create a healthy and responsive policing structure. We will continue working on this framework to test various what-if policing scenarios and generate useful information to better inform the scheduling and deployment strategies of police officers. Our work is always dedicated to maximizing the efficiency and effectiveness of patrol operations and minimize the stress level of police officers. Thank you so much.